morning. Today I introduce you the case study designing the Zealand University Hospital with MagiCAD. Here you can find the conference agenda. And I introduce myself, Politecnica, the New Zealand University Hospital, the design workflow, the challenge of the project, how MagiCAD helped in the project, and the data-driven map design. I'm Andrea Relli. I started in 2010 design with BIM software and worked in BIM methodology with ArchiCAD and Revit. In 2012 I started design of healthcare and public buildings. In 2015 I began the collaboration with Politecnica, and in 2018 obtained the master degree in BIM management at the University of Pisa. The last project I collaborated for Politecnica is the Zealand University Hospital, the Hospital of Sassari, the Africa Kidney Institute, another big hospital, the Hospital of Pordenone, and the Africa Kidney Institute in Nairobi. Introducing Politecnica. Politecnica is an engineering and architectural company establishment in 1972. And today has more than 240 professional architects, engineers and technicians. 43 of that are partners and has an average annual turnover of 18 million euros. The strengths of Politecnica are integration of expertise, from plan engineering to urban planning, from structural design to architectural designers, and teamwork in addition to the synergy of professionalism. Here you can see all the services offered, including BIM integration modeling, planning and design, safety coordination, master plans, compatibility studies, technical assistance, and others. Politecnica is an independent company where partners work in Italy and over 50 countries worldwide, guided by a common cultural and social vision, building for humans. In the last 3 years, have designed 64 new projects, has 6 offices in the world, and 7 project locations in the world. Is compliant with the main international standards, refer to the different areas for a design approach and respect the environmental limits, use the resource, and use renewable energy sources. Here you can see the main imaging of the hospital, the main rendering. The hospital is an extension to an existing building of about 150,000 gross square meters. For the project, Politecnica has designed the preliminary design, the detailed design, and health and safety coordination, for an amount about 310 million euros. The design has been divided into Phase 1 and Phase 2. For the Phase 1, Politecnica have developed the preliminary design that they have to be approved, the subcontractor selection, the budget development and approval. Then we had the employer approval, so we passed to the Phase 2, where we have to have the detailed design and construction in parallel with the design, and also the commissioning. Video introduces you the hospital. The organization and collaboration workflow involves more than 1,050 professionals working for client, design team, the consultant, construction team, the contractor. The overall workflow starts from 2D and the Z design, and then we have the checking and review phase and the digital and execution phase. Then the facility and operation phase. Every phase of the project has a specific software and tool that communicate each other with using the open exchange of formats. Here we see the BIM organization chart. Every part, client, contractor, and design team, has a BIM manager and a BIM coordinator. BIM manager and space programming meet each other in ICT forum where discuss some topics. Also, we have a BIM coordinator for each discipline and a BIM project coordinator for the clash between the various models. Here we see the tools that help us in the communication with the contract and the client. Trophus is the database, asset management, and the space programming, and help us to set the requirements and specification, to manage equipment, fixer, and fitting in the project. We have also model requirement, that is the requirement database, and help us to break down the requirements and check the project requirements are fully in according to and controlled. Appropriate and document procedure. The tool maintains traceability of all requirements for the initial development, from validation and verification in accordance with the approved verification method. We have also two common data environments, one with a client, Big Web, and one with a contractor, Autodesk BIM 360. Also, we have two matrices, the TAM matrix and the decision matrix. The decision matrix plan with presentation of applicable proposed solution. The TAM matrix, tasks, activities, and meetings, match with a complexity organization chart, since it was additional scope to clear up the role and the task section set up for roles, teams, and specialists, in order to have a balanced budget, people to be involved, and timing, a detailed schedule of meetings. Now we have some BIM numbers. We have over 60 Revit files, more than 300 added and filled parameters, more than 1,000 kilometers of mechanical and hydraulic sanitary ducts and pipe modeled, and more than 1,300,000 model objects. Every discipline has its model: furniture model, architectural model, electrical model, mechanical model, and structural model, and external wall model. All the disciplines are divided spatially in 4 different buildings, and in some cases thematically. For example, we have the facades models and the prefabricated bathroom models. Here you can see how all the system terminals have a model. All the map objects have been taken from MagiCAD libraries, with a greater saving of time, greater security on assurance on the project and features. For the project, prefabrication has been a must. In particular, the project is leading to the construction has been to define requisite and performance to define object and parameters. Then bring into BIM elements that compose the BIM files that help us for the request and quotation given to the contracts that makes the workshop drawings, and then we have the construction. Here you see the main prefabricated elements that we have: the load-bearing facade, the bathroom pods, and the prefab slabs. They passed from to be placeholder to a digital mock-up. So we have some placeholders in models. MagiCAD help us to his huge database of map families, and it has allowed us to be able to have a common dataset of families shared with all the mechanical system team members placed in two different subsidiaries that are developing at the same time the subdiscipline of this project. From the placeholder to the workshop drawings and BIM models, all the map families have been modeled and analyzed with MagiCAD. In particular, placeholder has some map object taken from MagiCAD libraries. Then we have a selection of supplier that with MagiCAD design the project of workshop drawings. So we have the approval of suppliers by Politecnica and by the contract. One time the supplier has been contractualized, so we have the workshop drawings. Here we see another example where all the features have been taken from the MagiCAD libraries. Every map element here has been taken from MagiCAD libraries. In this video, we can see the complexity of a corridor and an operating theater. Here we have the challenge of project divided in three parts. Part 1 is tailored design process to feed construction need, building well design, fast track and parallel beam, and the budget. Building well design requires a smart attitude and focus to merge needs and priorities, using appropriate tool to meet an appropriate budget and appropriate timing. Fast track and parallel beam side models tailored to all the client approvals, budget and time frame, supplier selection, workshop drawings, construction to be finally uploaded back into BIM. The word budget was twice mentioned on purpose. No budget respect, no party. Apart healthcare requirements, budget is always the driver for the decisions. Part 2. Product purchases and supplier selection. During the phase, we have the quantity takeoff extracted by models where MagiCAD help us. Drawing exactly by the models, technical specification, evaluation of the technical space by the contractor, selection supplier and contract. The part 3 is the interaction with stakeholders variation. Healthcare design is probably the most affected by changes, as a new inputs and late decisions always introduce risks. Changes are traditionally caused by the user needs, the new incoming equipments, passing of time which causes new expectations and performances, changes of technologies, variation and constant improvements of care services. All tools were not helping handle such issues. New tools certainly improve more interaction with stakeholders in the design phase, but changes are still an issue. Multi-input platforms, multi-actor and multi-levels, example Dirofus, ICT forums and others, are in fact making the decision environment more complex. Maybe coordination between tool and actors or a unique platform for interaction with stakeholders could be the next step. Now we'll see how MagiCAD helps us during the design phase. IFC models. MagiCAD has been very useful for us to export in IFC all the thousands of objects modeled and taken directly from MagiCAD library. With MagiCAD supports, MagiCAD speed up our work, especially by providing us an extensive selection of already made BIM objects for map design. The MagiCAD product database is dynamic and constantly updated with new products. We have used MagiCAD supports and hanger models with automatics the placement of suspension elements along ducts and pipes. Our customers appreciate the possibility to have supports and hangers included in the project drawings. And now, with MagiCAD, it is easy for us to meet this need. Clash detection. In the project we are dealing with multidisciplinary models of a great complexity, and clashes between all the disciplines is a big issue. The clash detection tool is a very helpful feature because of this friendly interface. It's easy to set the rules and the clash detection and allow every user to do a preliminary check of the model. This is a good practice to keep our model as free as possible of clashes. The drop report in the multi-level buildings like the College Oxford pressure drop calculations is an important part of the mechanical system design. The tools present in MagiCAD are well done and easy to use. We have to use these tools for pipes, ducts and sprinklers. Sound calculation. Our client asked us to respect the specific noise rates for each room templates of the hospital. So, with the sound calculation tool, we have to be able to check the noise of the duct system in all the rooms of the project. Now we have the data and map design. For us, data and map design is important for the cost simulation are more realistic when all the elements on a map design can be determined more accurately. Optimize map system in the design phase before they are installed in the buildings thanks to a rapid modeling. Improve time and cost saving during construction through a reduction of installation mistakes and material waste. Provide a better material estimates for the construction phase. Thank you very much. Thank you for your attention. Bye.